Okay, aerobic energy system. Study design. Rate and capacity. So how fast and how much energy, and also what fuels it uses produce ATP. As most of you should know already, the aerobic energy system provides us with ATP in the presence of oxygen. That is when our bodies have sufficient oxygen. We can then produce energy aerobically. With our aerobic energy system, it's very special. Unlike the other two systems that use only one type of fuel, the aerobic energy system can use the three nutrients, carbohydrates, fat and protein, as fuels that can be broken down to give us energy. This graph shows us the waste products when we utilise our aerobic systems broken down into glucose to give us ATP. Again, the pyruvic acid with sufficient oxygen gives us the ATP, as well as carbon dioxide and water. Here we can see that we get 36 ATP when we using the aerobic energy system. That's using carbohydrates. We can use glucose, which comes from glycogen or carbohydrates, free fatty acids from triglycerides, and amino acids from protein. Yes, we need oxygen, and we get carbon dioxide and water. And the great thing about the aerobic energy system, hours and hours and hours. It's your turtle. It's the tortoise and the hare. Our aerobic system is that ever-ready bunny that just keeps going and going and going. So this reminds us, this graph, that aerobic energy system, we can utilise fats. We could also use carbohydrates in the presence of oxygen, and proteins. However, protein is a last resort fuel. So here, when we start exercising, all three energy systems are activated, and as you can see, the aerobic system is the last system to be the major contributor of energy supply. So it's not until the athlete is working for around 30 seconds that the aerobic energy system becomes the major contributor. And as you can see, over time, the percentage of how much energy is being supplied aerobically increases, and towards, anything over about 2 minutes, anything over its 2 minutes is significantly aerobic. So getting back to the rate and the capacity, the rate of energy that the aerobic energy system can provide is quite slow, but its yield or its capacity is very large. The yield also depends on which nutrient, which of the carbohydrate, fats or proteins that the body's using to produce that energy. So we are just looking at the aerobic system at the moment. We can use carbohydrates that's stored as glycogen broken down into glucose that gives us a moderate rate, whereas when we use fatty acids, triglycerides broken down into fatty acids to produce ATP, it's much slower. And part of the reason is because it requires so much more oxygen to break those molecules down. So the rate is much slower. So the the two main fuel sources for aerobic, because protein is really only used in extreme circumstances. Carbohydrate, and it loves carbohydrates preferred, gives you faster but not as much fuel, whereas fats gives you a little bit slower rate but gives you a lot more. So the carbohydrates give you about 36 ATP, whereas fats give you about 147. But because triglycerides have 3 fatty acids, it's 147 times 3, which gives 441 ATP. So as you can see, fats, the yield is huge, but it has the very slowest rate. So why is this important? This is important because when our bodies have enough carbohydrates, if we've carbohydrate for extended events, if we've carbo loaded, our cells are bursting at the seams with stored glycogen, we can produce energy at a faster rate because once we run out of these carbohydrates, we are forced to use our fats to produce the energy, which is much slower. So this is why athletes for extended endurance events carbohydrate load, so we can get a faster rate. Remember that any activity that lasts over about 2 minutes is going to be predominantly aerobic. Although all 3 energy systems contribute, if we go back to the previous graph, this one reminds us that in an activity that requires you to go all out, after a good 60 seconds, it's predominantly aerobic. Okay, so anything that's over 2 minutes, as a general rule, is predominantly aerobic. So that is why aerobic athletes, particularly endurance athletes, try to minimize using their carbohydrates. They try and train their body to utilize fats as much as possible, because fats gives us heaps of energy, but it means that if we can save our carbohydrates, we can go faster for the overtakings or the surges or the finishes. So here's a summary of the aerobic energy system. Have a read through. The main points is that the system has a slower rate, but it's got a much bigger capacity. It can go for hours, days to provide energy. And although it has a slower rate, remember it is still activated as soon as we start exercising. It just doesn't contribute very much, because when we start exercising, if it's very intense, our body is mainly producing energy anaerobically because we're in oxygen deficit. Our heart rate hasn't been able to provide enough oxygen, but it is still contributing, although it's very small at the beginning, but it gets bigger as time progresses. So training the aerobic energy system, lots of ways to do that, mainly interval training again, and it's got to be over that 2 minutes because that's when you're predominantly working aerobically, and continuous, so that's your constant running or cycling or swimming, and we need to do that for a minimum at least 20 minutes, 20 to 30 minutes. The intensity is not as high, it's lower because it can't provide that faster rate. So 70 to 85% of your heart rate max. So that's around, say, 130 beats per minute to about 160 beats per minute. And our work to rest ratio is about 1. It could be a 1 to 2, or it could be a 2 to 1. You could work more than you rest. So here's just another slide repeating that, just to be more specific with the interval training, it's called medium or long interval training. Another method that we can use is fartlek, which is little sprints, jogging. So the work to rest ratio, so this is where we might work for say 4 minutes and then like go pretty reasonably hard, and then we might have 2 minutes easy, or we might do 10 minutes hard, 10 minutes easy, 1-to-1. And the recovery is active because we want to help keep delivering oxygen to muscles to help resynthesize ATP and remove waste products. So you want an